הדובר הראשון הוא פרופסור יאיר טאומן. אפשר לקרוא את ה-CV שלו, בתקציר CV שלו בחוברת, לא נלאה אתכם. בבקשה, יאיר.
דיברו אנגליש?
מה שאתה רוצה. מחיאות כפיים, כן, זה דבר טוב.
English or Hebrew? Okay. Gibberish, okay. So let me tell you, I'm a game theorist, and let me tell you what is it, game theory, so that we'll get at least, and I brought an example, which is very simplifying example, even less realistic, but just to get the flavor. But first of all, what is game theory? Game theory is mathematical models of conflicts with usually more than one decision maker, and the interaction, the analysis of the interaction between these decision makers is exactly the topic of game theory. As opposed to decision theory, decision theory deals with one single decision maker who has to take optimal decision under some uncertainty. But what I do as the single decision maker has no impact on your outcome. Let's say I want to invest $1,000, should I buy IBM or some bond or whatever? My decision will not affect you. I'm too small, okay? Usually that's the assumption to affect you. If, however, we are engaged in a conflict where my action is going to impact not only me, but also your outcome, and your action is going to impact me, and I have to take into account when I take my action how you're going to react to that, and you have to take into account how I'm going to react to your reaction, and that is the game theory. Actually, the first article in game theory was in 1921, and this was on chess. That's why it's called game theory, okay? Basically, I don't want to get into it, but basically chess is opened, okay? There is an optimal strategy. The question is, sometimes it's very interesting. You can prove that some conflict has optimal strategy, and it's an open question, what is this strategy? Okay, I can even tell you in some games that the one that started the game has a winning strategy, or the second one, and nobody knows what is it. Okay, there are, נפלאות התחום. Okay, so just to start, by the way, let me tell you, in the since 94, 11 people got a Nobel Prize on game theory. One of them is Israeli, Bob Aumann, who supervised my PhD in the Hebrew University. And there are 10 of them, all of them in economics, by the way, even though it's more mathematical field. And you know why it's not, you don't have a Nobel in mathematics? The story is that Alfred Nobel, his wife fooled around with a mathematician, and he was very upset, and he decided, no, it's very interesting. And the story, by the way, you can read it everywhere. Lately... Why there is no Nobel Prize in philosophy? By the way, my PhD as a mathematician, when you get it, is PhD in philosophy. Okay, so maybe he extended the action. But in any event, just to let you know, recently somebody discovered that he was never married, but it shouldn't ruin the story. Okay. Okay. So. The example I want to do, what I want to show you, one example, which is, I don't think that you're going to get it, just the flavor of it. I'll give you I'll explain it. But then I want to just tell you something about application of game theory to auctions, all kind of auctions. But that is not part of your theme. But so let me go through what I call cyber attack. How we pushed it? Okay. So let's take an example, okay? I cooked this example a few hours ago. So, so you have one attacker and one defender, okay? You tell me if it's any close to reality, but in any event. The attacker can choose one of two targets, okay? To hit strongly on some target, or to hit not in a strong way, not in a dramatic way. If you want to hit strongly, it's much more costly, Okay, so it depends what your target. The defender can choose one of two defense actions, either a radical one to protect, let's say, I mean here, just to simplify, let's say if you go for the radical one, you can really avoid any damage, okay, let's say. And, or, I mean, let's say there is some attack on the airport, on the all database and stuff like this on the airport. You can move all airplane out. You can avoid it, but under high cost. Or you don't take any action. I mean, just to simplify, or weak action, but let's say no action, okay? The radical strategy, as I say, is of high cost. Now, the problem is that the defender cannot, with certainty, identify the target. And he doesn't know the target. Well, he can operate some intelligence system, but intelligence system always give you some signal with noise, so you are not sure. You get some, it depends what is the precision, how accurate the intelligence system is, but you are not sure. So just as an example, by the way, let me describe in numbers. All these numbers, I mean, it's just cooking numbers, but let's say if let's say that I am the attacker, you are the defender. So if I go with strong action and you are fully protect, still it costs you. Therefore, you end up with -2, as opposed that you can, if you don't protect yourself, you end up with -5. And if I launch a weak attack against you, okay, and if you can avoid it, but on the cost of -2, and which here you get, if you use the radical, -3, and if you don't, otherwise -1. I could also get it -2, but let's say here I put -3 for me, just because I had to use too much power for a weak one, so I don't feel well for that. Okay, and -1 here. The same for you as a defender. Now,
test.
For me, by the way, if I win, sorry for the attacker, if I launch a strong one and you don't defend, I'm very happy. I'm getting 4. Less optimal one is, I'm sure you hear me, no? But in any event, okay. Second best for me is this one, namely that I launch a weak one, you protect fully, but you waste so much of your resources that it gives me a good kick out of it. And let's say this is one, and the worst case for me is that I spend, to launch a strong attack, I spend money and you completely avoid it, so it's -2 for me. Just, I mean, the numbers, experts should give me the numbers, okay? But under this assumption, and I say the defender cannot identify the target of the attacker with certainty. Now, what is the strategies of the attacker? Either to attack strong or to attack weak. The strategy of the defender is a little more complicated, okay? Do you know how many strategies the defender has? Actually, the defender has 4 strategies. What are the strategies? As a function of my signal, so the IS, I operate an IS. Okay, let me, before running to that. The defender operates an intelligence system. By the way, I have only 2 more slides, so just be patient. The defender operates an intelligence system, IS I called it, which is accurate with some probability. For this one, I am assuming 75%. What does it mean? It means the following. If the IS will send signal small s or small w to indicate that it's likely that it was strong one, or it's likely that it was weak one, the attack. Okay? The probability that the defender chooses the target S, chooses that the target S, if the signal is S, is 0.75. Namely, if I get from my intelligence system the signal small s, I should believe that means that with probability 3/4, 0.75, the attacker launch a strong attack against me. And otherwise, but I may have a mistake with probability 25%. And let's say the same probability if I launch a weak attack, then the signal will be a small w with the same probability 0.75. So with probability 75, I'll get the right signal. With probability 25, I'll get the wrong signal. Let me show you how I describe it in a tree form, okay? So here is the attacker. He can go strong. He can go weak. The defender cannot. Now, if he goes strong, I may hear for my intelligence system either the signal S or the signal W. Or, okay, but I don't know if it comes from a strong or from a weak. Also from a weak, I can hear the signal S. It's less likely, only probability 25%. That's the probability of a mistake. He launched a weak attack and I get the wrong signal. But I don't know if I'm here or here. That's why I indicated this with that rectangle, okay? And I can then, not knowing, do radical or do nothing. Radical or nothing. The same thing, the defender observes it should be small w, and then again he should do R or N, R or N. Okay. Now, that simple game, I computed in probably 20 minutes. And I got the optimal strategies of this. You can actually, by the way, what are the strategies? So the strategy of the attacker is either to go S or W. The strategy of the defender is what to do if he observes the signal small s, and what to do if he observes the signal small w. We have 4 strategies. For instance, I can say radical no matter what the signal is, one strategy. Another strategy, to do nothing no matter what is the signal. Another strategy, if the signal show me S, I'll go radical. If it shows me W, I'll go nothing. And opposite. Opposite doesn't make sense. If you analyze it, and we are almost done, we have to take expectations here and blah, blah. We get some payoffs. This is what the attacker gets, and this is what the other one, the radical, forget about, it's just to get the flavor. And you can see, for instance, that he will never use this one. This is, by the way, against the intuition. If you get strong, if you get the signal S, that more likely that it was strong attack, you do nothing. And if you get the signal W, which indicates that it's a weak attack, you go radical, doesn't make sense. And indeed, you can see, if I use this, I get negative 425, which is worse than negative 275, and negative 2.5 is worse than this. So for sure, I'm not going to use this, because this is completely dominated by this strategy. It turns out that I'm not also going to use this one, and the optimal solution, and that is my last slide here, is actually to play randomly. Now think of it as a repeated game. So if this is the case, my own strategy of the attacker strategy is out of 11 trial, he should launch 2 of them strong under these numbers, and 9 out of 11 a weak attack under these numbers. And why should play randomly and not deterministic? Because if you have an attacker that plays deterministic, you can figure out after a while what to do against him, because you will figure out, you easily would be able to identify his strategy. Therefore, the optimal strategy is a random strategy, okay? Where with probability 2 over 11 to launch strong attack, 9 over 11 weak attack, you never go for sure the radical one that is costly, but rather you just choose at random either that or that. But notice, in both cases, you have N and N, meaning no matter what, if you see the signal weak, you don't do anything. You react with N in both of them. However, if you see the signal strong, with probability in 12 over 9, you go with the radical strategy, and with probability 7 over 9, you get then to do nothing. Okay, this is just an example. Now, in general, you have many more strategies, but in principle, if you give the data and stuff like this, you can analyze the the optimal strategies of each one of the players. Okay, now that is, by the way, I was interviewed, there's a famous program by London and Kirschenbaum, and at that time there was once an attack, actually a Trojan horse, that some people from London tried to get into some computers of Israeli computers. I forgot exactly the details. And I was asked, what's, beside it, it's illegal, obviously. Why not to do it? You can benefit if you can, and let's say nobody find you out, you can benefit by putting a Trojan horse, okay, and extract data that may be useful for you. And my answer to them was, if I know that there is somebody that may come into my computer, I may feed my computer with data that may fool him around. But he also has to take this into account, okay? And this conflict, you can analyze it depending on the parameters. You can analyze what is the optimal strategies. Okay, that is up to now. I take 5 minutes just to tell you briefly how to use game theory in, it has a lot of application, let's say, for in auctions. So I don't know if you know, but there are several auctions, ascending one, the English auction, where you sell stuff in an ascending order, or you have sealed bid auctions. So let me give you an example. Suppose you have an auction for a picture, and everyone submit a bid. We open up all the bids simultaneously. The highest bidder wins. But the highest bidder pays his or her bid. That is called first price auction. Now, second price auction. Second price auction is the same thing. The highest bidder wins, but doesn't pay his bid, but pay the second highest bid. Is this clear? Now, you have a picture. Would you sell it in a first price auction or in a second price auction? Remember, in the first you get the highest bid, in the second you get the second highest bid. You sell it in first or second. So there's no clear answer, but in general, you can prove mathematically even that you are better off selling it in a second price auction. Intuition, the result is mathematical result. Intuition, obviously my strategy will be different if I play second price auction, where I know that if I win I don't pay my bid, than if I play a first price auction, where I know that if I win, I have to pay what I say. So I have to be much more careful in a first price auction than in a second price auction. And it turns out that in a second price auction, the second highest bid is higher than the first bid in a first price auction, in general. Now you can ask, and by the way, have you heard about second price auction? That you open up, the highest bidder wins and pay the second highest bid? It's very rare probably. Let me tell you, most of the auctions in the world are of the type second price auction. And let me just give you an example. Suppose that we are in the ascending auction. Okay, and let's say that Gabi and myself are there. My strategy is to bid for the picture up to 100, and Gabi is up to 120. So in that ascending... Don't worry, Gabi, don't worry. But in any event, Gabi is up. His strategy is to go, he can do it on eBay, putting automatic bid, outbid everyone up to 120. I put an automatic bid, outbid everyone up to 100. 100, I'm out. I don't want to pay that much. So we start, let's say the auction starts, we get 79, both of us are in, 90, we're in, 99, we're here, 100, I'm out. He gets the picture for 100. Even though his strategy was to put 120. So actually, eBay, all the ascending auctions, second price auction are all the same. And they give more than the first price auction in general. Let me just finish by, in case you bid on eBay, you may want to hear what is the optimal strategy bidding on eBay. I can tell you exactly what is the optimal strategy bidding if you want to bid on eBay. So on that one, look on the object, and think how much you're really ready to pay at most. Let's say that I'm ready to pay at most 100. Let me tell you what it means. It means that for 101, I'm out. If I get it for 100, I'm completely indifferent between buying it and paying 100 or not buying it at all. So 100 is no deal for me. I'll get it or not get it. I don't care. 100. If I get it for 90, I make 10 because I was willing up to 100, but I bought. So obviously in a first price auction, it's crazy to put your valuation 100 because you get 0 no matter if you win or lose. But in a second price auction, English auction, the ascending one, or eBay auction, the Japanese auction, there are many auctions, your optimal strategy, no matter what the others are doing, is to put your valuation. So it's not open to any strategic manipulation. You don't need to think usually what the other one will do. I don't care what you do. I can prove it to you, maybe in the break if you want. It's just exercise of a kid of, let's say, 12 years old, no mathematics. I can prove it to you that no matter what your strategies is, or I mean the other ones are, my best strategy is to bid my valuation. If you do it, at least you are acting smart. I think I'll stop here. Am I correct? Yes.